Okay, so I am, for 1A especially, we already did this page, but just for review and in case anyone else doesn't get to this page, I'm going to do this real quick. So we are solving exponential functions. We have if we have the same base, then the exponents are equal. So here, 2 is the same base, so x equals 3. We have the same base, so 2x equals 4. I have to solve, and x equals 2. Bases are the same, so we can set x minus 3 equal to 7, and x equals, add 3 to both sides, x equals 10. If two powers with the same base are equal, then the powers are equal. The bases are, if you can get equal bases, then you can set the powers equal to each other and solve, and the powers will also be equal. Okay, solving by equating exponents. If the base can be made equal. Sometimes you have a question like this, where we have 4 to the 2x equals 32 to the x minus 1. Well, right now the bases aren't equal, so rewrite each power with the same base. I can rewrite 4 as 2 squared. I can write 32 as 2 to the 5th. I have rewritten 4 and 32. 4 and 32. That's all I've done so far. Now, what do I have? I have, this was was to the 2x power. 4 to the 2x. This was 32 to the what? X minus 1. So I set the bases equal. I just rewrite them and then multiply by whatever's left up there. So this now, power of a power property. So I have this will equal to this. The exponents will be equal, so I can set them equal. 2 times 2x is equal to 5 times x minus 1. Solve it. This is 4x equals, distribute, 5x minus 5. Subtract 4x from both sides and you get x. Add 5 to both sides and you get x equals 5. Check your solution by substitution. To check, I plug 5 into the original equation. So 4 to the 2 times 5 is equal to 32 to the 5 minus 1. 4 to the 10th is equal to 32 to the 4th. Well, when I do that on my calculator, I get I get both sides equal to 104.8576 is equal to 104.8576. Check. That's how I can check that. All right, let's do the next. If we do this, how can I make these equal bases? Well, I recognize it's got to be a 3 something. So what is 9? 3 squared is equal to 81 can be written as 3 to the 4th. So far, all I've done is rewrite those numbers. This is times 2x, and this is times 3x minus 2. Okay, that's what was already there. Now, the bases are the same, so I can set the exponents equal to one another. And I get 2 times 2x is equal to 4 times 3x minus 2. 4x equals 12x minus 8. Subtract 4x from both sides and you get 8x. Add 8 to both sides and you get 8x equals 8. X equals 1. So, find the same bases. Rewrite those powers in terms of base 3, then set the exponents equal to one another. Okay, so now we're moving on. If you haven't already, please stop the tape and do that problem, okay, to check yourself. So, now we're going to solve exponential functions by taking a log of each side. Take a log with the correct base of each side, cancel the log with the base. What the heck does that mean? Well, if I have 4 to the x, how can I get rid of that 4? I want to get to the x, right? We're always about solving for x. So I take the log base 4 of both sides, okay? Why base 4? because this is 4 to the x. And if I take the log base 4 of 4 to whatever, who cares, they will cancel to 1, and I'll be left with x. And if I take the log of the other side, well, this is just a number. So I can take my calculator and say math log base 4 to the 15th is 1.95. Now, remember, if I don't have that function on my calculator, I can do the change of base formula, the log of the big number, 15, divided by the log of the little base number. And I get the same thing, 1.953. So x is 1.953. So just to set you up, what would I do here? I would take the log base 5 of the left side is equal to the log base 5 of the right side. And I'm going to get x equals whatever this number is. So go ahead, try those two, see what you do. I'll have the answer up next class. Now let's move on when you get a little more complicated. We're still taking the log of each side. That's still how we're going to solve when we have some base. But what we first have to do is get rid of whatever is attached to that. So I need to get rid of that -3. Isolate the base and the exponent. So what am I going to do? I am going to subtract 3 from both sides. So I have 5 to the x minus 2. Those cancel, is equal to 25 minus 3 is 22. Now here I am. What do I do with that? I take the log of each side. Of what base? The log, what's going to cancel that 5? Log base 5 of 5 to the x minus 2 is equal to the log base 5 of 22. Just a number. Just a number. These cancel. I get x minus 2 equals, what number is that? I just do that on my calculator. Log base 5 of 22 is equal to 1.92. Now, I'm still not done because I don't have x by itself, but it's easy enough. It's just algebra. Add 2 to both sides. X equals 3.92. And that is my answer. Do one more together. I'm going to subtract 8 from both sides. I'm isolating this base and exponent. So those cancel, giving me 10 to the 5x plus 4 on the left is equal to 35 minus 8, which is 27. Now, I have a base 10 here, so I'm going to take the log base 10 of 10 to the 5x plus 4 is equal to the log base 10 of 27. I recognize that as the common log, but I just wanted to see why this was canceling. So these cancel, leaving me 5x plus 4 equals the log of 27. So I do that on my calculator, the log of 27, and that is equal to 1.431. 1.431. I'm still not done. I have to subtract 4 from that to get 5x equals negative 2.569, and I divide that by both sides by 5. And I finally get x equals negative 0.514. Okay, so it's a teeny bit of work there, but that is what I get. So let me just do this one together, just so you don't get stumped. What is divide by 40, divide by 40? This cancels. I get e to the 0.6x, 0.6, but that's fine, equals 240 divided by 40 is 6. How do I get rid of, I have base e. Well, I want the log base e, which is the natural log of e to the 0.6x is equal to the natural log of 6. Take the log of both sides. These cancel, giving me 0.6x equals, I take the natural log of 6. I get 1.792. Now I'm going to divide both sides by 0.6. And that will give me 2.987. X equals 2.987. And that is how I take the log of both sides. Okay, so you should be very ready to do your homework. See you next class.